Purpose of this video is to show you how to run case-based micro-simulations in Complexit. If you look at the suite of techniques available so far, what we've been looking at in the previous videos is how to import your cases and build a case-based database. Again, using, in this example, the Welsh Multiple Deprivation Index. And it's really focused on clustering cases using k-means, corroborating them using the self-organizing neural net, and then exploring the solution in the SOM map to better understand the cases and the complex causality associated with them relative to their cluster membership. But there's a next step in the process that we've developed, which is then giving users the opportunity to explore how various interventions on those clusters and cases might change their overall position or situation. In the case of the Welsh Multiple Deprivation Index, for example, one of the things we might be concerned with is taking communities or cases that are struggling with extreme forms of deprivation and driving those communities via some policy or community-based intervention to a better place. It's because of that that we developed this concept that we call case-based micro-simulation. In terms of wording for a second, just to note, ex ante is Latin for before the event. What case-based micro-simulation is doing is looking at this potential for making interventions before some future scenario takes place. For example, where a community is presently at and where it's going, and then to look at interventions into the present state of that case or cluster to see potentially where it might head. Ex post is what we're primarily doing when we're doing these case-based analyses, which is you have some results and you want to explore them after the fact to see how it is that those results have impacted the cases that you're studying. So again, in terms of thinking about Complexit, this case-based micro-simulation, as you see here, is an ex-ante evaluation tool. It can be based on real or artificial data. So far, we've been using real to produce realistic future projections of status quo trends, what would happen if things just continued as they are, or to test what-if scenarios by making some type of intervention based on real or imagined data or policy procedures, and then to explore the consequences of that. There's a lot of advantages to that because in comparison to, say, other conventional approaches to micro-simulation, we're looking at clusters and making interventions on those clusters, and we're doing that from a process that starts with the ex-post analysis of data and moving all the way to the ex-ante evaluation. So that's all fancy vocabulary. Let's get down to the nitty-gritty in terms of how it actually works. Again, as with most tabs, it's pretty straightforward. You will see that the first step is to set up the model. You'll notice here we have the 1, 2, 3, 4, 5, 6, 6 by 6 grid that we used in the analysis of the data that we brought in from the Welsh Multiple Deprivation Index. So we have 36 quadrants, and on our new simulated environment, we have the same 36 cluster quadrants. Here, however, we have something slightly different. The first step after setting up the model is to run the cluster solution. What we have now, in comparison to this, where we have the actual cases and the cluster membership, we simplify things a bit by actually plotting the clusters on the grid solution. So if you look at the profile, the bar chart that we get when we run the visualization, you can see, again, here are the quadrants and here are the profiles on our 7 factors. And for those who are potentially watching this video for the first time, and not the others preceding it, these are our 7 factors. So you see that in the simulation, we have, again, those 7 factors and how their profile is outlined for the different quadrants. And then we can see how the actual clusters are positioned. So a step forward on this is in the regular SOM solution, you have your cases with their cluster membership. Here, however, you have just the clusters. The reason we went with just the clusters is it allows for, as we've said throughout this, an intuitive and interactive way of exploring possibilities with your data to come up, in this case, with possible interventions to change the situation that you've been analyzing. In addition to the grid, we also have the cluster profile for each of the major clusters. If you go back to the clustering of cases, this is the exact same thing we have here. Cluster 1, 11.66. And in our policy thing here, we have 11.67 rounded up just to make it to 2 decimal points. So these are the 6 clusters that we arrived at in our previous analyses using the k-means and SOM solution and exploring the best model of fit. If you'll notice here, for example, looking at for cluster 4, which has one of the highest rates of income deprivation as compared to, say, cluster 1, which has the lowest levels, you look over here and you can see the clusters are identified by color. Cluster 4, being yellow, is up here, and cluster 1, being dark green, is down here. And that makes sense that they would be on opposite sides of the grid because this is a community with some of the worst deprivation, and this is a community with some of the best outcomes relative to income and other key measures. Over here, we have also then the clusters outlined, which we will then later explore further when it comes to running our sensitivity analysis. But for now, it's about thinking about the various interventions that might be made. Again, this is where working with other experts, working with colleagues, working with citizen scientists, working with people in the community, one can sit down and explore, what if we did this? What if we did that? Would that make a difference? Would it drive the community, in this case, in the direction we want to go? So here we're going to look at cluster 4, which is again up here. And cluster 4 has some of the highest rates of income deprivation, employment deprivation, highest percentage of people with low birth weights upon birth for children, some of the highest death rates, and some of the lowest scores on students' overall preparedness for graduation and beyond, some of the highest rates of violence, and also some of the highest rates of theft. So sitting down with people, one might say, well, if we were to make an intervention over the next year, 2 years, whatever the policy cycle is, we think we could bring income deprivation down. Well, how much could we bring it down? Perhaps we could bring it down from 22 to 20. So let's ask the question, does that make a significant change? So can we drive this perhaps closer to this? Running our cluster solution, we see that it does not move that community or the set of communities that are connected to that cluster. And if we go down here, we can see that obviously getting this level of deprivation to move is going to be difficult. Getting all the way over here is most likely an impossibility. The idea that one can take a poor community and make it a rich community in a matter of years is obviously moot. However, we might be able to drive it closer to one of these other quadrants, quadrant 30, quadrant 29 perhaps, or around. To get a better feel for that, we go back to the ex post analysis to our SOM map and just take a look at the prototypes. If you watched from previous videos, you'll know that the prototypes are really, they're the factors. And the nice thing about looking at the prototypes is whether or not a particular case or cluster is on that quadrant, we can still nonetheless see what the profile in that looks like. So driving the cluster over here towards this direction could be potentially useful, perhaps getting it down to slightly lower levels and making an intervention that has some significant impact. So one could go down and say, well, what if, let's back this up, and this is nice here, we have these tabs which allow us to go forward to the intervention you just made, or just back up and rerun the cluster solution, set it up as it presently is, and then explore again. What if we could get this down to 18? Dropping income, and we could also improve employment slightly by getting that down to 17. Let's go see if that is a sufficient intervention. It is not. It is still not moving that community. One of the things that we very much sought to accomplish in the construction of this micro simulation, case-based micro simulation, is a realistic simulated environment, and that sounds like a contradiction in terms, but a simulated environment that was as close to realistic as possible, meaning in the real world, it is very difficult to change things. One could simply just start dropping the numbers across all of these and then obviously drive it, and that would make this environment sort of not really potentially interesting or useful because that would be obvious. But where it gets interesting is really in sort of thinking about what real potentials could take place. For example, again, if this could be driven down to 18, this could be driven down to 17, and there's the potential also to reduce or improve educational well-being. If we put this here, sorry, went wrong direction. If we put this up a little bit, and so we improved education, we improved job growth and employment. What sort of intervention would that result in? It's still not able to move that cluster. So we see that a singular intervention into, say, income or employment with a slightly improved intervention into education is not sufficient. One of the things that seems probably very important for this cluster is to also bring down violence. If violence, for example, in the area could be brought down, we can see if that, in addition, would provide the type of impact that we're looking for. It again is not. So this is, again, the type of utility that comes from this is providing a realistic scenario for interventions, makes you really think through what types of accomplishments one could make, and again, to drive it, to repeat this point. So let's see if improving income deprivation is sufficient to make a movement. It again is not, right? So you see these sort of singular targeted interventions that are typical of most policies are not sufficient to actually move communities often, as this example shows, but making some sort of more systematic intervention. One would hope then one could make a medical intervention, for example, and improve mortality rates and so forth might be a good idea here. So let's try an overall systematic intervention and see if we get change. We do. So we see that moving the community in this instance from a position of extreme deprivation would require some type of systematic effort across institutions, improving income and employment, for example, reducing disparities in mortality and birth weight, making some sort of intervention into education, and a reduction in crime. These sort of small interventions across a variety of indicators would then lead to the type of success that one would be looking for in terms of driving communities, in this case, into a state of better well-being. And so that's the purpose of micro-based or case-based micro simulation, is to give you the opportunity to explore these different type scenarios and to get a feel for what potentially might be a useful set of interventions to improve the particular cases one is studying.